Hi, and welcome to Programming Like It's 1979, NAND to Tetris. Let's build a computer from scratch. Today is a setup day. We're going to walk you through getting the software that you need to take this class and get you started. We're going to begin by going to the URL nand2tetris.org. That is 2 as in the numeral 2. There's a lot of great information here, and I do encourage you to look at the entire website, but for today, we're going to go to the Software tab, and we're going to download the software from this link here. Download the NAND to Tetris software suite. And now that we have it downloaded, I'm going to flip over to my terminal. And we should see that it's in our downloads folder. I'm doing this on macOS. If you're doing this on Windows, the process should be very similar. If there is appetite for me to walk through this on Windows, I can certainly record it from there. But the basic process is going to be more or less the same. I'm just going to keep this folder in my desktop for now. Let's take a look at what's in it. We'll have two directories. One is called Projects and one is called Tools. The Tools directory is where all of the programs you're going to run to test and validate your solutions live. And the Projects directory contains the Projects directory contains just a bunch of other directories that go through the course week by week. You can ignore week 0. Week 0 is used for if you're taking this class with an automated grading system, you would submit that class, but we're not doing that obviously on this YouTube version. And we can see that there's lots of files here that we're going to use as we get into the class. For right now, let's go back to the Tools directory. And you're going to be running the batch files here if you're on Windows, or you're going to be running the sh files here if you're on Mac OS or indeed Linux. For the first few weeks of the course, we're primarily going to be using the hardware simulator. And we could just run that from the command line just like this. And there's our hardware simulator. You can see we've got some Java errors in the background right there. I wouldn't worry about those. To use the hardware simulator, we're going to show you that once we actually start writing code. But let's take a look at what happens if we try to run one of these assignments without actually doing any of the work. I'm going to choose Load Chip. So the first chip we're going to be doing in NAND to Tetris is the NOT chip. So let's go straight to our NAND to Tetris 01 directory and let's choose not.hdl. We're going to load that chip. We can see here is the definition of the chip. Right now it has no definition at all. And we could load a script with that, and we're going to load the test file for not, which is not.tst. We're going to load that script. This is the test definition, and we're going to run the test. We're going to choose Run, and I expect it to error out because we haven't created this chip yet. We go through, and indeed, we get this comparison failure at line 2. So that is the hardware simulator. Get used to it. You're going to be spending a lot of time here. The last thing you're going to need is a text editor. And I have chosen to use Visual Studio Code. And the reason for that is very simple. It's that it has a number of add-ons that you can get that will understand our HDL files. The HDL language being used by this class is not terribly intricate, but it is nice to have, a little syntax coloration while we're doing our work. The last tool I'm going to be using is Helmut Niemann's digital circuit drawing program. Digital logic design program. You don't have to use that one, and I am only using it for ease of explanation. As we go through this course, as we design chips it can be a little dry to just look at code. So I am going to go through and build these chips in code, but I'm also, in most cases, also going to draw them out to make it a little more visually interesting and to provide a different handle for the visual learners out there. That's what you need to get started. I will see you in the next video where we are going to actually start building our very first chip, the NOT chip. This has been Programming Like It's 1979. Thanks for watching.